Good morning, everybody. I introduce myself. My name is T. Henson. I am working as assistant professor in the Department of Mathematics, St. Joseph's College of Arts and Science, Cuddalore. I am going to teach Allied Mathematics 2 for first BSc Computer Science. Unit 5. Topic is finite difference. In the topic, we are going to see the Newton's forward and backward formula. So using that formula, we will find the intermediate value, that is f of 43 and f of 84. And that should be done in the following problem. So I read the problem. From the following data, find y at x equal to 43, at x equal to 84. The x values are given 40, 50, 60, 70, 80, 90. The y values are 184, 204, 226, 250, 276, 304. Now we write the solution for this problem. Since x equal to 43 is near the beginning of the table, so we use Newton's forward interpolation formula. So for that, we need the difference table. So this is the difference table. In this table, the x values are written. The corresponding y values are written. Here we have to calculate delta y, the first forward difference. You subtract the first value from the second value, write the answer in the center. That means 204 minus 184, that is equal to 20. Similarly, you subtract the next level, you subtract this value from this and write the answer in the center. Similarly, next level, subtract this number from this, write the answer in the center. Similarly, you can proceed this for all other values. So we have obtained the first forward difference delta y. Similarly, we calculate the second forward difference delta square y. You subtract the first value from the second, write the answer in the center. That means 22 minus 20, that is equal to 2. Similarly, 24 minus 22, that is 2. Similarly, 26 minus 24, that is 2. 28 minus 26, that is 2. So this is second forward difference. Similarly, we calculate third forward difference, delta cube y. You subtract first value from second, write the answer in the center. 2 minus 2, 0. Similarly, 2 minus 2, 0. 2 minus 2, 0. So this is delta cube y. Similarly, we calculate delta power 4y. That is a fourth difference column. Here, subtract first value from second, write the answer in the center. Similarly, we can do this. We have two values in fourth difference column. Next, we have a fifth difference column, delta power 5y. So that is 0. So we can extend the formula for Newton's interpolation up to fifth difference. So now we write the formula. Newton's forward interpolation formula is f of x equal to f of x naught plus nh equal to y naught plus n into delta y naught plus n into n minus 1 by 2 factorial into delta square y naught plus n into n minus 1 into n minus 2 divided by 3 factorial into delta cube y naught plus n into n minus 1 into n minus 2 into n minus 3 divided by 4 factorial into delta power 4 y naught plus n into n minus 1 into n minus 2 into n minus 3 into n minus 4 by 5 factorial into delta power 5 y naught. Here we have to find f of 43. So f of 43, here x is 43. So x naught plus nh equal to 43. X naught is starting value. Your starting value is 40. That can be taken as x naught. So x naught equal to 40. H value is 10. That is the difference in x. And that is to be represented as h value. Here 40, 50, 60, 70. The difference is h. So that h value can be taken as 10. Now we have to calculate n. So using this expression, now we see how to calculate n. nh equal to 43 minus x naught. So n equal to 43 minus 40 by 10. That is equal to 3 by 10. So n value is 0.3. Here we have rounded the top values in this difference table, and they are to be substituted in the formula. So that is that x naught value is 40, y naught value is 184, delta y naught value is 20, delta square y naught value is 2, delta cube y naught is 0, delta power 4 y naught is 0, delta power 5 y naught is 0. And these values are required and they are to be substituted in the formula. So now we are going to substitute all the values in this formula. So here we have to calculate the intermediate value f of 43. Here f of 43 equal, this is y naught. Y naught value is 184. Here y naught value, this is 184. This value is to be substituted here. According to this formula, y naught is 184 plus n into delta y naught. N value is 0.3 and this is delta y naught. Delta y naught can be taken from the table of a difference table, that is delta y naught. And this value is to be taken and it is to be substituted in this formula. So n into delta y naught plus n into n minus 1 by 2 factorial. 2 factorial is 2 into delta square y naught. Delta square y naught can be taken from the tabular column. So this is a delta square y naught, that is 2. And that is to be substituted here. So n into n minus 1 by 2 factorial into delta square y naught, that is 2. Plus n into n minus 1 into n minus 2 divided by 3 factorial is 6 into delta cube y naught. Delta cube y naught is 0. Plus n into n minus 1 into n minus 2 into n minus 3 divided by 4 factorial. 4 factorial is 24 into delta power 4 y naught, that is 0. Plus n into n minus 1 into n minus 2 into n minus 3 into n minus 4 divided by 5 factorial. 5 factorial is 120 into delta power 5 y naught, that is 0. So these last 3 values will be 0. So we have to calculate only first 3 terms. It is 184 plus, when you simplify this, we get a 6 plus, when you simplify this expression, we get a minus 0.21 plus all other values are 0. When you add these two values, we get f of 43 equal to 189.79. This completes the first part of the problem. Now we have to do the second part of the problem. That is, you have to find f of 84. So since x equal to 84, here we see the table. X equal to 84 is near the end of the value. Therefore, we use Newton's backward interpolation formula. So since x equal to 84 is the nearly end of the table, so we use a backward interpolation formula. So for that, first we construct the difference table. This is x values and this is y values. This is del y, del square y, del cube y, del power 4y, del power 5y. Here the calculations to be done from bottom to top. Here this is x naught value and this is y naught value. We have to calculate the first backward difference del y from bottom to top. Here you subtract first value from the second, write the answer in the center. Similarly, that means 304 minus 276, that is 28. Similarly, you subtract this value from this and write the answer in the center. That means 276 minus 250, that is 26. Similarly, you subtract this value from this, write the answer in the center. That is 250 minus 226, that is equal to 24. Similarly, you subtract this value from this, write the answer in the center. That is 226 minus 204, that is equal to 22. Similarly, you subtract first value from second, write the answer in the center. That is 204 minus 184, that is 20. So this is the first backward difference. Similarly, we calculate the same logic is to be followed here. We calculate second backward difference del square y, that is 2, 2, 2, 2. Then similarly, we calculate third backward difference del cube y, that is 0, 0, 0. Similarly, fourth backward difference del power 4 y, 0, 0. Then fifth backward difference del power 5 y, that is 0. This is the last column. Hereafter, we cannot proceed. So now we use the Newton's backward interpolation formula. That is f of x equal to f of x naught plus nh equal to y naught plus n into del y naught plus n into n plus 1 by 2 factorial into del square y naught plus n into n plus 1 into n plus 2 divided by 3 factorial, that is 6 into del cube y naught plus n into n plus 1 into n plus 2 into n plus 3 divided by 4 factorial, that is 24 into del power 4 y naught plus n into n plus 1 into n plus 2 into n plus 3 into n plus 4 divided by 5 factorial, that is 120 into del power 5 y naught. Here x naught plus nh value is 84. Here n equal to 84 minus x naught by h. Here x naught value is 90. So this is x naught value and this is y naught value. And this is del y naught value, del square y naught value, del cube y naught value, del power 4 y naught value, del power 5 y naught value. These values are required and they are to be substituted in this Newton's backward interpolation formula. Right. So here x naught is 90. So 84 minus 90 by 10. H value is 10. So here we see the difference 40, 50, 60, 70, 80, 90. So from this we find the difference in x is 10 and that is to be taken as a h value. That is h is 10. When you simplify this, we get n equal to minus 0.6. So all the values, here the rounded values and the obtained value n equal to minus 0.6, that is to be substituted in this formula f of x. F of x equal to, this is y naught value, that is y naught value is 304 and that is to be substituted here, y naught plus n into del y naught. N value is minus 0.6 into del y naught value is 28. See, this is a del y naught and that is to be substituted. Plus n into n plus 1 minus 0.6 into minus 0.6 plus 1 by 2 factorial into del square y naught. Del square y naught value is 2. Then after that, all the values are 0, del cube, del power 4, del power 5. These values are 0. When they are to be substituted in this formula, the three expression values will be 0. Here we get 0. Here we get 0. In this expression also we get 0. So when you simplify this, we get 304 minus 16.8 minus 0.24, the 3 zeros. When you add these two, add these values, we get f of 84 equal to 286.96. Right. Next problem. We calculate the value of y when x equal to 0.47 from the following data. Here x values are given, here y values are given. Here now we write the solution. Since x equal to 0.47 is nearly the end value of the table, so we use Newton's backward interpolation formula. That is f of x equal to f of x naught plus nh. That is y naught. This is the formula, y naught plus n into del y naught plus n into n plus 1 by 2 factorial into del square y naught plus n into n plus 1 into n plus 2 divided by 3 factorial, that is 6 into del cube y naught. Similarly, this expression into del power 4 y naught and this is del power 5 y naught. Now we have to construct the difference table. Here x values are written. This is y values, and del y, del square values, del cube values, del power 4 values, del power 5 values. Here we calculate the difference, the backward difference. That is to be started from bottom to top. This is a x0 value, this is y0 value. We calculate the first backward difference. You subtract first value from the second, write the answer in the center. That means 1.7974 minus 1.5836. When we get 0.2138. Similarly, we can perform all other calculations. So this is first backward difference, del y. Similarly, we calculate a second backward difference, del square y. That is, you subtract this value from this, write the answer in the center. Similarly, you subtract this value from this, write the answer in the center. Similarly, we can perform the same logic for all other values. So this del square y. Similarly, we calculate del cube y. In del cube y, you subtract this value from this and write the answer in the center. Similarly, you subtract this value from this, write the answer in the center. You subtract this value from this, write the answer in the center. We have three values in del cube y. In del power 4y, we have two values. And then del power 5, in del power 5, we have only one value. This is the last column. Here we cannot, hereafter we cannot proceed. Here we have to find the intermediate value f of 0.47. So that is x equal to, we take a 0.47. X is nothing but x0 plus nh. Here x0 is the starting value, that is 0.5. That is to be obtained from this table, 0.5. Here x0 value is 0.5. H is the difference, common difference in x. So that is to be identified from these values, 0.1, 0.2, 0.3, 0.4. The H, we see that the H value is 0.1. So H is equal to 0.1. We have to find N. So N equal to 0.47 minus 0.5 divided by 0.1. So that is N equal to minus 0.3. Here the rounded values are to be taken and they are to be substituted in this Newton's backward interpolation formula. That is f of x, f of 0.47 equal to, this is y0. Y0 value is 1.7974 and that is to be substituted, plus n into del y0 plus n into n plus 1 by 2 factor into del square y0 plus n into n plus 1 into n plus 2 divided by 3 factorial, that is 6 into del square y0. Similarly, del cube y0, del power 4 y0 and del power 5 y0. All the values are to be substituted in this formula, and using scientific calculator, we can simplify this. And finally, we get the answer f of 0.47 equal to 1.7301. This completes the problem. Thank you.